Hello, everyone, and welcome to the English Hour. In today's episode, we'll talk about a fantastic topic. I think it's an amazing topic, and it's also a very popular topic. What is that?
That's going to be artificial intelligence, or as almost the world knows, it's AI.
Yeah, AI for short. So, AI or artificial intelligence, I think it's the pinnacle of computer engineering. It's the pinnacle of cognitive science because the ultimate goal is to make sure that, or to create machines that can think and that can behave the way humans do. And it's an incredible goal, and it might seem a little bit far-fetched, but I think we're somehow making progress.
Yeah, we seem to be making progress, and at the same time, I think there is a lot of psychological value to this because it is something that excites so many people. It's like the whole humanity is excited, fascinated with the idea of giving rise to thinking machines. It's almost like, there's another frontier, the space frontier.
Yeah.
Is like we're going to go to another planet, we're going to live, and we're going to be a space-faring civilization. That's what they call it. And everybody's so excited. Since childhood, we dream of things like that. And this is one of those things, robots. And maybe the connotations are not as positive as in the case of space all the time. Because, we see that, Matrix, for example, right? Things go awry, but at the same time, it's so exciting.
Well, honestly, I think not all the connotations of space are favorable because we have dreams or nightmares of alien invasion.
Yeah, the contact.
Yeah,
exactly.
Well, the thing is, in the case of AI, there are a lot of heated discussions.
That's
because
right.
The first discussion is on the nature of AI.
Yeah.
And a lot of people argue that AI is not possible. Then on the other hand, a lot of people argue that AI is possible. And it really goes back to understanding what thinking really is, what cognition really is. So there has been a lot of heated debate on this topic, especially in the last maybe 50 years with the start of the cognitive revolution, which really goes into the human brain. And another discussion is on the outcomes of AI. So one part of the discussion is whether AI or thinking on the part of machines is possible, and the other main discussion is the outcomes of the AI. So there are people who spell disastrous consequences, and there are people who think that AI will be a lifesaver or savior for the humanity. And there is a lot of disagreement and there is a lot of uncharted territory because we don't have previous examples, we don't have precedents, so we really don't know what's going to happen. So I think we might start out with the first question of whether machines can think.
That's a good start. I think to keep everybody on board, we can maybe go ahead and give a working definition of what artificial intelligence could be, because it's so hard to pinpoint a definition, but we can maybe start with something. Do you want to take a shot?
Yeah, well, I don't know what to say. So, if we evaluate AI in its strong form, like the way humans think, then I think AI would or could be defined as the ability to interpret information and act on that information, the ability to interact with the environment, collect information, interpret that information, and react or respond to the environment based on that information.
Like a human being.
Like a human being, and with some sort of metacognition, because you do something, but you know why you're doing it, because as humans, we have actions, behaviors, and we can think about our actions and behaviors. We don't carry out those actions mindlessly. So there is this metacognition level, like thinking about your own thinking. And I think that's the cream on the top.
Well, basically, would it be fair to say that artificial intelligence is an intelligence that is human-like in its ability to think
Yeah.
and interpret and have judgment.
I think this really brings up a great point, because there is a famous test to determine whether artificial intelligence can achieve human-like performance, and it's called Turing Test.
The Turing Test, yes.
I'm sure you're familiar with it.
Yep.
Alan Turing. So
Yeah.
a famous British math scientist or professor,
Yeah.
I'd call him. So Alan Turing devised this test. And in this test, you are maybe using a computer to write to a person or a computer in another room. So in one room, there is a person, and in the other room, there is a computer. So you don't know who you're writing to. So
That's right.
on your computer, you are chatting with someone in the other room. You don't know if that's a person or a computer. And if the computer can persuade you that it's a human, then you pass the Turing test.
The computer passes the Turing test.
Yeah. And I think that's ingenious, because
That is right.
like, I think language is one of the milestones or one of the manifestations of human cognition and intelligence.
One of the hallmarks of being a human being.
And if a computer can really write like a human, chat like a human, and make us believe that it's a human, I think that's a great indicator of a cognition or intelligence. So that's a famous test, but then there was a counter argument to Turing test, and it's called the Chinese room argument or Chinese room experiment by philosopher John Searle, I think.
That's right.
And in that experiment, do you remember that experiment?
Exactly, yeah.
Okay, can you give us some background with that experiment?
Yeah, as far as I can remember, the Chinese room experiment is about decoding a language, right? You've said that, you know, these people, this machine and this person are separated. One is in one room and the other is another room, so they don't have direct interaction. So you don't know what you're up against. And I think in this case also there's, you know, this setup, right?
They're
divided.
Setup.
Yeah, it's a similar setup. They're divided, you know, in the sense that one is in one room and the other is another room. And this is a thought experiment. First of all, we have to say that this is not a real thing. John Searle just says that, you know, I don't think basically what he says is, I don't think Turing test is really valid. He argues that the ability to respond in a human fashion, in a human-like fashion, does not mean that you have created a human-like mind in a machine. That's his argument. He's arguing against the strong AI, the AI capable of human thought. So he says, can you set the scene for the Chinese room experiment?
Yeah, I think in the Chinese room experiment, so like there is a room and there is a guy in the room who doesn't know Chinese.
That's right.
Well, think of an English or an American guy in a room who doesn't speak.
Any American guy.
Yeah. He doesn't speak Chinese. He doesn't know a word of Chinese. But there is a Chinese booklet or so. So he's in the room. Someone, maybe a Chinese person, comes in front of the room and puts in a Chinese card. Maybe there is an instruction on it. So the person in the room does not know Chinese. So he cannot really respond to it. He doesn't know Chinese. But there are operating guidelines. Like if you see this sign, do this. If you see this sign, do that. If you see this Chinese sign, do that. So the person doesn't really know or understand Chinese, but since he has that guideline, based on that guideline, he can carry out commands. And in this case, John Searle argues that, well, you see, from an outside perspective, you would think that the person in the room knows perfect Chinese because, like, you give him commands in Chinese and he can carry out those commands. But you know that that person doesn't really know a word of Chinese. He's just using some tricks to respond to those requests. And it's a very interesting argument.
It's an interesting argument.
It's a very interesting argument.
It reminds me of something called parroting, right? Parroting means you follow something and repeat something like a parrot does. And what a parrot does is, a parrot is perfectly capable of speaking human language on the surface. It looks like, it can pronounce every single word that you can, and I can.
Even better than we do.
Even better in certain cases, because a parrot can successfully carry out and mimic a standard pronunciation of a language, whereas you might be using an accent or a dialect, so its pronunciation, it's better. As in some, it depends on the perspective. But the point is, a parrot does that just by listening to, memorizing, and repeating phonological input. It gets the sound and it repeats, it mimics the sound. It does, as far as we have understood, as far as the scientific method has been able to confirm, the parrot has absolutely no idea what it is saying. So the semantic content is completely empty.
That is true.
When we say something, when we use the words, we try to communicate a message. We have an idea that we want to talk about. So the words, they just come rolling out. We don't really think about every single word that we're trying to say. On the other hand, a parrot says exactly what he or she has heard. It has heard. So there's no meaning at all. Yeah. So I guess it's very similar in the sense that, this robot can actually do things in a way that is so sophisticated that you think that it is intelligent. However, it is actually not intelligent because it's just following the commands.
Yeah, well, I think in that case, we can talk about weak AI, because in the weak AI case, you argue that human-like behavior or intelligence is possible to a certain degree. You cannot achieve full human performance. And you know what? There are arguments for why that is the case. Mm-hmm. And one of those arguments is embodied cognition. When I learned that term, it was a groundbreaker for me, because embodied cognition basically means...
I'm sorry to interject, but I would like to remind the audience here that Hussein is basically somebody who is an expert at this, because he has been a student of cognitive science for the past 6 years, and he studied language before, and we studied language together at Boğaziçi University. He then carried on and did a master's at cognitive science in Boğaziçi. So he has experience, and he is very enthusiastic about this. So when he talks about cognitive science, that's his party, basically. Yeah. So just go ahead and when you talk about this, I just want to remind people that this is something that you've invested a lot of effort and thought into.
Thank you, sir. Okay, so one of the concepts, as I said, that was an eye-opener for me was embodied cognition. And the main premise is this: you cannot separate cognition from your body. So your body, your senses, the available means of stimuli will definitely shape your cognition. So if you want to achieve human-like performance,
you need a human body.
Yes, you basically need a replica of human body, because think of it. A computer can see in 360 degrees if you want it to. Yeah. But a human can only see the front, maybe the sides, but not the back part.
Yeah.
Or we have our hands and the tactile stimuli and everything else. So human cognition is inherently tied to human body. If we had a different body, our cognition of the world, our understanding of the world, spaces, environment, time, everything would change.
That's right.
So the embodied cognition argument is very interesting in that regard. So,
I agree.
So in order to create human-like cognition, you have to make sure that the machines are in the human form. And there is another, this isn't really, I think this isn't essentially related to this AI argument, but there is an interesting experiment with robots. So robots can seem very friendly or very creepy. And there is a fine line in that distinction. So we were, I think, in class, we're talking about an experiment in which people were shown different robot faces. And the more human-like it gets, the more scary it can become. So if it's very human-like, then you can be more scared.
People creep out.
Yeah.
Rather than reacting sympathetically, they creep out.
Up to a certain point, so it might resemble a human. Up to a certain point, it's favorable. But if it really looks like a human, then it becomes creepy.
That's interesting.
So that was an interesting point.
Everybody can attest to this, I think. For example, personally, I saw the Cosmo, I guess, like little robot that moves around the table. It looks like a car almost, but it has a face. It's that LCD face. It's not 3D or anything. It's just, these neon signs. It looks like a neon sign, but there are facial expressions on it and psychological. Like there's a game you can play with the game. You play with it, the game. Like there's a game, and then it's a reaction game. You just tap on boxes, and it taps on boxes too. And when you win, it gets angry or it gets sad. Or when it wins, it holds up the hands. It looks like actually a bulldozer, but holds that up and just cheers and that radiant smile. And that's very cute to me. Yeah. But when I see one of those like full-fledged human body robots and they're trying to smile and they're trying to talk, and those like little facial expressions get lost, it's very similar. It's almost there, but it's not. And I get creeped out. I don't want to keep looking at it. So I can totally understand that.
Yeah.
But, at the same time, maybe we can go ahead and continue from the weak versus strong debate, because it very much ties back to what AI is and where AI goes. So basically, weak AI is all the AI that we have so far been able to produce, right?
Yeah. Well, the surprising thing is most people are unaware of the applications of AI. So AI is a very popular term, like people hear about artificial intelligence, but most people don't really know what it is and how it's applied in real life. And believe me, it's being used in forms that you would never imagine. For example, AI is used to give some examples, AI is used in face detection. For example, when you upload a photo to Instagram or Facebook, and when the application suggests that, oh, this is your friend, would you like to suggest it? So the computer can basically read someone's face and make sure or match that face with an identity. So one application is face recognition, or in large scale, it can be used for monitoring an entire population. For example, in China, the police started wearing glasses that in an instant search millions of faces in a database of criminals, and then if the police, like the glasses, can tell the police whether the people in their vision or in their field of view are criminals or not, so that they can apprehend them. So that's very interesting.
Very interesting.
Another point of use is e-commerce and behavioral manipulation. So for example, I think AI is also very much related to big data. So, for example, Facebook, Amazon, Google, they know a lot about you. They collect data on your interactions online. So
That's right.
Amazon knows, for example, if you buy something, Amazon knows what you're likely to buy next. Or if you search for something, Google knows what you're likely to search next, and they use this information to sell you products, to sell your information to advertisers, and they can even manipulate you with that information. So AI is very much in use in forms that we do not notice. It's a part of our life. Or, for example, I think you can consider like speech recognition as a form of AI. It's a very useful form of AI.
Yeah, it is, definitely. Because it is going beyond that phonological re-representation. It's actually giving you like semantics-based content. It's giving you meaning.
Maybe in the future we'll talk to computers or phones. We already do. We have voice assistants, right?
Exactly. Like Google Assistant and Siri are both very successful implementations of this weak AI that we're using. And they're actually the zenith, they're the top form of weak AI. They can do a lot of things very well, but they can't carry out a natural human conversation. You can't expect an answer to every single question that you pose to Google Assistant. And, they're trying to kind of patch it up by saying, I don't know, every time you ask them something and they don't have the database to give you a response.
Yeah.
However, you can't really do that as a human. I mean, after a while it gets old and even the responses get repetitive, but it's still fun,
Yeah,
it's
it
still
is.
exciting. It's still exciting to ask silly questions to Google Assistant, like just tell me a joke or something. And it goes ahead and tells you a joke about like 3 people go into a club or something.
Yeah.
It's funny stuff.
It is.
It's like you can ask Siri, you can tell Siri that you love Siri, and then it would respond, oh, thank you, that's very cool, something like. Or you can go ahead and call, like you can press the button on an iPhone, and then like the Siri comes up, you press and hold, and the Siri did it comes up, and then you can say, hey Google, and to trip it up, and then it's gonna say something like, I'm not Google, I'm Siri, or something like that.
Yeah.
So it's cool. But the real thing is there is something called strong AI, which is the idealist original definition of AI, which is thinking
like a
machines.
human does.
Exactly. Thinking like a human does.
But you said something very interesting, so sorry to interrupt, but so you said they're trying to patch it up. So there are shortcomings in the current AI applications, but we can definitely say that AI is growing stronger. So AI at this point might not be at its strongest, but it's getting definitely stronger thanks to the computing power, thanks to the data available, and thanks to the resources. For example, autonomous driving is one of the applications of AI.
That's right.
It's been very popular in the last decade, I would say.
Yeah.
A lot of companies are trying to invest in that field and trying to poach top talent.
That's right.
And it's become a very active field of research endeavor. And I think it's definitely getting stronger. One day it might get to the point where it's really strong.
Exactly. I mean, for example, with the, automated driving experience, it has grown to a point where they're actually doing the test drives of driverless cars in the United States. And for the most part, it has been successful, although it has come to a bottleneck right now because of a fatality that happened recently. But that's a different discussion. It's definitely growing and it's getting much better. And Elon Musk is not somebody that we haven't talked about on this podcast.
Yeah.
I think we've been referring to him over and over because he's somebody that is really exciting in the sense that...
Is that the final frontier?
Yeah, he's pushing the envelope when, in terms of AI, in terms of spacefaring as well. A lot of things that we are interested in, he is also interested in. However, the thing is, the way AI grows is important to discuss here, I think, because there are some thresholds, there are some points of breakout, like great success, great evolution, maybe not evolution but revolution. That's the very fast growth and development. And the issue is we might be approaching one of those, and it is the issue of supercomputers and quantum computing. So you've already identified the factors of growth for AI, which are big data and computing power.
Yes.
Right? 2 critical factors. There are more, but these seem to be, the main blockage, the main fundamentals of AI growth.
And plus, you need some brilliant minds.
That's right. You always need that for everything, but definitely true. So the supercomputers and the computing power, I think that's a very interesting area because the data is driven by processing. If you don't have processing power, you're not going to have data. So you will
not be able to make use of your data.
Exactly, that's true. And you're not going to store the data that you're not going to be able to make use of. There is a parity. There is a correlation between the size of data and the processing that goes with that.
Yeah.
So you can find an example of that in gaming, for example. Like games used to be much more simplistic. They had no claim of being realistic at all. Like Super Mario, for example, Mario Brothers didn't try to look human. They were just little pixels, dots on the screen. But now the level of realism is huge.
Yeah.
It's scary how real it gets. And also the interfaces change too. Like you had screens, and that all you had for decades. That's all you've had. Now you have the goggles, the virtual headsets. And you can see the world through those virtual headsets, and the resolution keeps getting higher and higher.
Yeah.
Maybe to a point where, you're not going to be able to even recognize the difference between real and fantasy.
That's virtual reality.
That's right. And virtual reality is also another, important AI implementation, a whole area of AI implementation in of itself. But going back to computers, so you need stronger computers to be able to, more powerful
Sure.
computers to do this. And there is this new frontier, and it's called quantum computing.
Yes.
And that's very interesting.
It is. I think like the spread of the internet, what brought about the developments in supercomputers is basically the spread of the internet and the connected systems. For example, in the past you had, maybe if you are a sole researcher working on your own, you would have to buy a lot of devices and storage units and processors to carry out complex calculations. But right now, thanks to cloud computing, you can pay for daily, or you can pay monthly, and you can basically rent thousands of computers to do complex processing. And
cloud computing.
Yeah, cloud computing. So it really opened up new possibilities for a lot of researchers who would otherwise not be able to carry out such experiments.
Because they don't have the financial ability to install all of those hardware and everything.
Yeah, that is true.
Yeah.
So the biggest players on that front are Amazon Web Services, AWS. It's I think it's the biggest right now. It's got a huge infrastructure because Amazon processes millions of orders every year, so they have a very strong, maybe the best backbone, and they're followed, I think, by Google, so Google Cloud Platform. So those are like the guerrilla players in the field.
Yeah.
They have a lot of power, a lot of infrastructure. So, and one thing that a lot of Westerners are not really aware of is that China is making great strides in that field.
Exactly.
Because they have Alibaba Group, and they have Baidu. It's like the equivalent of Google in China, and they have made huge investments in AI, and I think they're reaping the benefits. But I think the West isn't really aware of what's going on there.
That's
so it's a different market.
They also actually have the strongest, most powerful supercomputer in the world too. China is like on the top 10 list. China has a few computers actually making that list, and the top place is actually also Chinese as well.
Well, they're flexing their muscles. They have been flexing their muscles for the past 2 decades.
That's right. Remember when we were talking about Amazon being up against brick and mortar shops?
Yeah.
Amazon is actually more brick and mortar than actual brick and mortar shops now because of all the hardware that they have.
That is true.
The servers, the computers, everything.
Well, but people don't have access to those.
That's
they
right.
only have online access.
That's right. Now they're opening up stores too.
Oh, well, but it's an AI-based store.
That's full AI. That's a very interesting example of AI.
It's a combination of computer vision and a lot of sensors and a lot of advanced computing, because like you go into the store, there are no clerks, there are no cashiers, no employees in the store. Just go into the store, buy whatever you want. The cameras will follow you around, and they will use computer vision to see which products you put into your bag and which you put back and everything else. They'll just follow you around the store, and you'll just walk out, and Amazon will deduct the pay from your credit card that they have on file. So it's incredible.
It sounds incredible, exactly. And they have an implementation of that. There's an actual store in the United
Seattle.
States. I think that's where they're based, so they probably put it up there. It's an actual
Amazon
store.
Go. I think.
And you go in, you pick up whatever you want, and then you just go out.
Yeah.
Like you don't even. It seems like you don't even make a payment. However, you actually do, because everything you do in that store is being followed by like numerous
sensors, cameras, and everything.
Exactly. First of all, you get identified. That's an important thing to talk about.
Oh, yeah.
Because privacy in today's world is an important concern for a lot of
Privacy
people.
is a myth in today's world.
It's a myth, unfortunately. And you get identified by Amazon computers. They know who you are. They associate you with a financial method of payment.
Yeah.
And in this case, in many cases, most cases, this is a credit card or a debit card.
Yeah.
You get identified with that debit card account or credit card account, and then you get charged based on what you get out of that store. That's amazing technology.
It is.
It's crazy. Like they're able to follow everybody without missing a beat, without missing any movement, anything. And nothing gets tricked. Like you don't get more stuff and then get charged by for less or otherwise. It's hard. I mean, they haven't implemented it everywhere. If the technology was ready, I think they would already do that.
I mean, I think it's a beta test because I mean, the theoretical implementation of a system and its real life implementation can differ drastically. So
that's right.
You have a great plan, you have a great idea, the system is ready, but you have to put it to real life test. So in this case, they're doing that. And maybe there are shortcomings, the problems they haven't thought about before.
Little children nicking stuff and then not putting them back.
Yeah, that is true. There are a lot of scenarios that might go wrong or that might not have been calculated. So that one test stores gives them a lot of information input, and based on that they can really improve it, because I mean it's in a lot of AI applications there is continuous learning.
That's right. Exactly.
I think we can really talk about
machine learning.
AlphaGo and machine learning. So
yeah, we can definitely talk about that.
So Google acquired a company called, I think, Deep Learning or something. DeepMind. Okay, it's a London-based company. It's DeepMind. Google acquired DeepMind, and DeepMind produces algorithms or systems, machine learning systems, and they're very powerful. So they created an online player, AlphaGo, I think is what it is called. And AlphaGo was able to beat the masters of the Go game, or chess. Right. Was simple for it. They conquered the chess front and they went with the Go game because I think it's more unstructured and unpredictable. But the computer was able to. Times over. Yes, the computer was able to learn the game by playing it millions of times, and it was eventually able to sort of beat the masters, and that was a big deal. Yeah, that was a big leap, and it sent shockwaves around the earth, I think.
I totally
with regards to the potential of the AI.
Yeah, and you know what? It might even have led to cultural self-questioning as well. Like people thought, especially people in Far Asia, they thought that they had the most sophisticated game on the face of the earth. They looked at chess as being inferior to Go, because Go, because of the way it's laid out, has so immensely more, like thousands of times more possibilities, permutations built into it. So it is much harder for a computer to mimic the way a human being performs while playing Go. So with chess, I think it's been 2 decades now that chess has been conquered. Yeah. So already we have a robot chess champion. Human beings can't really anymore duke it out with a machine chess player. However, Go was not that way. Because
it was unpredictable.
It was unpredictable. It was very hard to program for Go, but now they have done it, and this is a true testament to how far AI has been able to come. And I think the only note that I've left to talk about is I think about the quantum computing here, and it's very interesting. It's a very interesting possibility because it seems like the world of quantum processing, the world of quantum mechanics, is trying to, the scientific circles working on this are trying to come up with a computer that is just incomparably more powerful to the supercomputers of this day and age. And they want to do this by changing the very basic structure of how a computer operates and what it is made of. And we're talking about bits here. We're talking about storage units that are going to be completely different in terms of architecture.
Yeah.
So a qubit, they're talking about a qubit, a quantum bit, which is able to process more information, store more information than a regular bit does. And based on that, they're thinking they're going to be able to use many, much fewer numbers, components of storage units, but they're going to be able to derive so much more benefit out of them. So I think that's the plan. And over the next 5 to 10 years, we might actually see a quantum computer, which would be amazing. And I am so thrilled, I'm exhilarated to see what it is capable of.
Well, the thing is, our plan was to talk about the strong and the weak AI forms, and then talk about the outcomes of the AI. And since this is a very, very broad issue, I think we'll just keep it, the first episode on AI can be just about the strong AI, weak AI, and the implementations of AI. And I think we'll need another episode to talk about the outcomes and the positive and negative sides of the AI and what it holds for us in the future. So I think we'll need another episode, and I think we need to leave the office to go out for dinner, and our phone started ringing. So I think it's time to go, and it's time to say goodbye.
Yeah.
So we'll see you in the next episode, and it's been a very enjoyable episode for us, and I hope you enjoyed it as well.
All right. Bye-bye.
Bye-bye.